Welcome to this explainer. Today, we're zooming all the way from the massive global impact of aerospace right down to the intense day-to-day reality of a four-year engineering degree. Aerospace engineering is absolutely one of the most prestigious and thrilling branches of engineering out there. We're talking about a field that literally reaches for the stars, taking us from the Wright brothers' very first flight all the way to modern hypersonic aircraft and Mars rovers. So, whether you're actively considering this as a career path, or you're just genuinely fascinated by how humanity continues to conquer the skies, this explainer is going to give you a complete, clear picture of what this industry truly entails. Here is our agenda for today. 1. The macro view. 2. The four-year curriculum. 3. A day in the life. 4. Careers and compensation. 5. Innovation and AI trends. And finally, 6. Is aerospace for you? Section 1. The macro view, establishing the immense scale of the aerospace industry. To truly understand aerospace engineering, we first need to look at the sheer scale of what this field is building. Look at this staggering number, $60.94 billion. That is the expected global aerospace AI market by 2035. And it's not just a Western phenomenon. India's own space economy is literally hurtling towards $44 billion by 2033, with private space startups raising thousands of crores in recent funding. The economic engine of aerospace is massive, and it is absolutely flush with capital and opportunity. To give you an idea of the complexity we're dealing with, a modern Boeing 787 contains over 2.3 million perfectly integrated parts. Just let that absurdity sink in for a second. 2.3 million parts. It isn't just about making things fly. It's about seamlessly integrating millions of components, from advanced avionics to composite materials, just to optimize safety, weight, and fuel efficiency. Every single piece has to work together flawlessly. And the economics of space, well, they've completely shifted. Historically, just getting a kilogram into space cost around $10,000. But thanks to reusable rockets pioneered by companies like SpaceX, that cost has been slashed to under $2,000 a kilogram. By actually landing first-stage boosters vertically, they've completely revolutionized the industry's economics. It's what makes satellite mega-constellations and commercial space exploration a reality today. Section 2. The four-year curriculum, the academic crucible of an aerospace engineer. So, before you can revolutionize space travel, you actually have to survive the curriculum. You'll start year 1 with foundational calculus, linear algebra, and classical mechanics. Then year 2 hits, and you dive right into core specializations like thermodynamics and fluid mechanics. Year 3, that's where it gets really exciting. You do a deep dive into aerodynamics, aircraft structures, and you actually get your hands dirty in wind tunnel testing to visualize airflow. Finally, year 4 is all about advanced computational fluid dynamics, or CFD, and it all wraps up with a massive 6 to 8 month capstone project where you might design an entire rocket engine or a UAV from scratch. Section 3. A day in the life. The reality of the job on a random Tuesday. Okay, so you've survived the degree, you've got the math down, but what does a random Tuesday actually look like in the workforce? Well, the reality is it's highly methodical. Your morning usually kicks off with a team stand-up to coordinate with the structures and systems guys. Then you're setting up these incredibly complex CFD simulations to test a new wing design. And here's the reality check. You're going to spend hours just waiting for those computations to run on a high-performance cluster. It's usually a great time to grab a coffee, right? Then the afternoon rolls around, and you're in intense multidisciplinary design reviews, negotiating trade-offs. Because sure, your perfect low-drag wing shape might be awesome, but if it's too heavy for the structures team or too expensive to manufacture, you've got to pivot. Engineering is really all about intelligent compromise. Section 4. Careers and compensation, mapping the professional landscape and financial realities. So what does this highly specialized skill set actually pay? Well, the financial landscape is very regional. In India, entry-level roles at elite space startups offer super stable growth, usually starting between 6 to 10 lakhs per annum and scaling up to 50 lakhs or more for senior technical directors. Now, over in the US, compensation is significantly higher. Senior roles can fetch up to $180,000. But keep in mind the hidden costs. Getting there means navigating the H-1B visa lottery, dealing with strict defense clearance hurdles if you're not a citizen, and, of course, facing way higher living expenses. After graduation, you're going to hit a major crossroads. Do you jump straight into the workforce to build industry context and start making money? Or do you double down? Pursuing higher education abroad or at an elite domestic institute is definitely a sacrifice, but it unlocks doors to highly specialized, premium-paying roles. Those advanced degrees in areas like computational aerodynamics or advanced composites, they command top-tier salaries and are basically required for high-end R&D gigs. Section 5. Innovation and AI Trends. How AI and emerging tech are reshaping the field. The aerospace industry is moving at breakneck speed, and AI is completely flipping the script on how we design and maintain aircraft. Take a look at predictive maintenance. By using AI to analyze massive streams of sensor data from engines, airlines are predicting failures literally weeks before they happen. This is slashing unscheduled maintenance by up to 30%. For airlines, that means millions of dollars saved. For you and me, it means no more sitting at the gate for 3 hours because of a surprise engine issue. And it goes way beyond maintenance. Generative AI is now creating these organic, biomorphic cabin brackets, designs that actually look more like human bone structures than traditional airplane parts. And they're 45% lighter. Plus, startups like Agnicol are 3D printing entire rocket engines in a single piece. No way, right? That eliminates thousands of joints and welds. And we absolutely can't forget the massive push for sustainable aviation, like hydrogen fuel cells and electric vertical takeoff and landing air taxis. These innovations are creating brand new job categories that literally didn't even exist 5 years ago. Section 6 is Aerospace for You, the ultimate decision framework. We've zoomed in, we've zoomed out. Now we arrive at the most important part of this explainer, deciding if you are truly built for this incredibly demanding industry. Let's do an honest assessment here. On the pros side, you're working with cutting-edge tech, you get immense prestige, and you have massive real-world impact. You're designing things that safely carry millions of people. But you have to weigh that against the cons. You're facing the grueling reality of intense calculus and differential equations. You also have to be willing to pack up and move to specific aerospace hubs, like Bangalore, Seattle, or Toulouse. And maybe the biggest reality check, you've got to be comfortable with incredibly slow, methodical product development cycles. We're talking 5 to 10 years before an aircraft even enters service. Knowing that this path demands unparalleled patience, heavy-duty math skills, and a genuine intrinsic fascination with overcoming gravity, I'm going to leave you with this final thought. Are you truly ready to design the future of human mobility? If you find yourself looking up every single time an airplane flies overhead, wondering exactly how it works, well then this just might be exactly where you belong. Thanks for hanging out with me for this explainer. Stay curious and keep learning.